What is inflation? How do we measure inflation? And how do we incorporate the effects of inflation in equivalence calculation? These are very important questions that we need to address in this course. What is really inflation? I'm sure some of you guys have an idea as to what an inflation is. You probably hear the term around, especially nowadays. Basically, inflation is interpreted by three basic interpretations. The first one is value of money. As you all know, money has certain value. For example, if you use a $100 bill, you would get you can buy some tangible what I call stuff with it. You can buy food with it. You can buy other things with it. You may buy anything you really like with that $100. But that $100 can certain power. You cannot buy, for example, something that is worth more than $100 with that. For example, with $100, you cannot buy a brand new car nowadays, and that means the value of the $100 bill that you have is a certain value, and it has a certain purchasing power. Also, if you deposit that $100 in the bank, it also has a certain earning power. It cannot earn, let's say, 500% of its own value. So money itself has a purchasing power and earning power, and the earning power itself would provide us with investment opportunities. If we can invest our money wisely, then theoretically we should supposed to pretty much make more money on it. So inflation is really a simple term. It is decrease in purchasing power of, for example, the $100 bill that I just discussed with you. So a decrease in the purchasing power is called inflation, and an increase in purchasing power is called deflation. You probably also heard the term deflation, which is could be interpreted as the opposite to inflation, and that is increase in purchasing power. So what is wrong with that? Why can we increase the purchasing power and thus increasing the value of money? In some cases, we actually do, but that is really a pretty complicated topic that is really beyond the scope of our class. But for the sake of this class, again, decrease in purchasing power is called inflation, and decrease in purchasing power is called inflation, and increase in purchasing power is called deflation. So let's take a look at this. So here's one example. Back in 1990, you could buy 50 Big Macs in year 1990. Big Macs, for those of you that are not familiar with the term, is if you go to fast food restaurants, McDonald's, they used to have this huge sandwich is called Big Macs. Some of them they still do, and I just haven't been there for a while. So in 1990, you could buy 50 Big Macs with $100. In 2003, you could buy 40 Big Macs with $100. So it used to be that it was $2 per unit, but it is now turned out to be $2.5 per unit. Again, there is a price change due to inflation, and over that 13-year period, that is turned out to be 25%. Okay, so the $100 in year 2003 has only $80 worth purchasing power of 1990. That's what we mean by $1990 and today's dollars. So another example, let's imagine that you could purchase 63.69 gallons of unleaded gasoline a year ago, and assume, again, for the sake of argument, this is not true, but for the sake of argument, assume that it is $1.57 per gallon, and a year later is $1.25 per gallon. That is a 20.38 change in price due to deflation. So deflation also happens, although it may not be widespread, but in the case of gasoline, sometimes that happens. So let me introduce some terminology to you. Two index that we use when we talk about inflation. The government use different indices to measure inflation, and two of the commonly used ones are given here. One is the PPI, or Producer Price Index. It's a statistical measure of industrial price change compiled monthly by Bureau of Labor Statistics, U.S. Department of Labor. So it really not just one data, it's a statistical measure of industrial price change because of so many industries that are involved, and we can only do a statistical measure to be as accurate as possible. The next one that is also commonly used is the Consumer Price Index, or CPI. Consumer Price Index is a statistical measure of change over time of the prices of goods and services in major expenditure groups: food, housing, apparel, transportation, and medical care, typically purchased by urban consumers. So this is very interesting because for those of you that have not heard the Consumer Price Index, you have heard about it before, but you don't know what it was, this should provide you now with some insight as to what it is. So food, housing, apparel, transportation, and medical care, and they all fall under the category of some of the major expenditure groups, and that are pretty much measured in Consumer Price Index. Remember, both of these are index. Please keep that in mind. They are a statistical measure of change over time. Again, these are important information to remember for your own knowledge, also for the exam. And this change, of course, occurs over time, and it's important to realize what those major expenditure groups are, so we can make much better decisions when the CPI is available to us. Two other terminologies: average inflation rate versus general inflation rate. The average inflation rate is shown by F, small f, a single rate that accounts for the effect of varying yearly inflation rates over a period of several years. Okay, very important to realize that it is a single rate, but it's supposed to capture the effects of yearly inflation rates over a period of several years. The other one, F bar, is the general inflation rate. The general inflation rate is the, there's a bar right over F in case you're missing that bar. The average inflation rate calculated based on the CPI for all items in the market basket. So there are differences between average inflation rate and general inflation rate, and one must be very careful with this terminology. So the Consumer Price Index, or CPI, again, there is a market basket, and it compares the cost of a sample market basket of goods and services. This market basket doesn't necessarily have to be goods, but it could also be services in a specific period relative to the cost of the same market basket in an earlier reference period. This reference period is designed as the base period. So again, an example is given here for the base period of 1982 to 84. If we put that $100 as a base period, then in 2002, it is the same things that you could do. The same goods and services that we could buy for $100 at that time, now we need to buy it for $179.90. So the CPI of 2002 was actually 179.9. So it's very important to realize that would be the consumer price index for 2002, 179.9. Okay, so that's important to define here. So again, the base period in this case is $100 in the example I gave you. So here's an example of the selected price indexes. Selected price indexes between 1993 and 2002. Again, year is given here in this table. The old CPI was established in 1967. From time to time, governments need to go ahead and actually correct those. So this is the new one in 1982 to 84. It's not new for now, but in 1982 to 1984 and 1993, after almost 10 years that the new CPI, Consumer Price Index, established, then $144 was the CPI. And the old one, if you want to compare it to the 1967 one, is $461.20. And gasoline in 1982, 63.9. Steel in 1982, 116, 129.8. Again, this is as of 1993, but in comparison with 1982, the year is also given here, and note that they're not all the same. Okay, and in 2002, that 144 now is 178.9, 535.8, and so on. So again, let's take a look at how we can actually use inflation, the average inflation rate. Let's say the base price for year 0 is $100, and the inflation rate for year 1 is 4%. The inflation rate for year 2 is 8%. What would be the average rate over 2 years? Again, the average rate over 2 years. So first, we would find the actual inflated price at the end of year 2. Before I go any further, without knowing, without having the knowledge of economic analysis and not knowing how to solve this problem, you would probably add 8 and 4 together. That'd be 12 divided by 2. That'd be 6%, an average inflation rate over 2 years. Whereas that could be close to the answer in this case. That's not really the answer. The answer is 5.98%, okay, not 6%. So again, we use a formula here, and we find the actual inflated price at the end of year 2 instead of using the interest rate. In this case, we use the inflation rate. And as you can see, 1 plus 0.04, and year 2, that is 8%, so 1 plus 0.08. It turned out to be that the power of $100 is actually reduced now, so we need more money now. We need $12.32 more over that 2 years for this problem. So if we could buy something for $100, best price year 0, we can't do that at the end of year 2. At the end of year 2, we need to spend $112.32 to be able to perform the same type of purchasing that we did at year 0 with $100. So we would find the average inflation rate by solving the following equivalence equations. Again, similar to the interest rate. Instead of I, we use the um, we use F instead, and we calculate it as 5.98. Again, this is pretty much due to the compounding power that applies to interest rate. In this case, it applies to the inflation rate. So let's take a look at some items here in order to better understand average inflation rate. The consumer price index in 2000, 171.2. That's the 2000 price. 2003 price was 184.20. And the average inflation rate is 2.47%. I'm sure you can guess by now how you can actually calculate that. Again, we just did a similar calculations. The average inflation rates are not available for this problem, but the average inflation rate in percentage is 2.47% for the CPI from 2000 to 2003. The postage, the price of a stamp for regular mail, one envelope, it was 0.33 in 2000, and it was in 2003 it was 0.37. So the average inflation rate for that stamp itself was 6.44. Okay. So this is not 2.47. That is 6.44%. Homeowner insurance, it used to be for the same home $500 back in 2000. So that went up by 7.56%. The private college tuition and fees went up 5.6%. The gasoline went up 1.89%. The haircut 4.55%. And the car, in this case, Toyota Camry, 1.56%. Natural gas, MBTU, it increased by 21.38%. Basketball ticket, 3.9%. And the cable TV, 9.07. Now, you probably do understand why the governments are worried so much about the energy and the energy resources and all that. Because, as you can see, if you have a number like that here in your CPI, this number here would really affect your CPI unless you throw it out of the basket and say, this is not part of CPI anymore. So the government is known to do that sometimes. That's why it's very difficult to, in global economy, it's very difficult to be able to come up with one way of measuring all that, because different countries, they don't follow what we follow here. So it makes it very complicated. But as you can see, this one number, the natural gas MBTU, really throws us off, by a huge amount. Everything else is between 1 to 7.56, 8, 9%. All of a sudden, you have this number that is jumped by that. Now, it would be really good if industries, they look at these consumer price index and they adjust the price of their products accordingly. And it is shown that when you follow that type of a pattern, you actually have a better success in selling your products. And many companies, they do that. So let me show you two ways of measuring inflation rate: general inflation rate, or F bar. Again, the average inflation rate based on the CPI. In terms of the CPI, we define the general inflation rate as the CPI sub n. Again, this is just a sub n is given here. It's the CPI of the base plus 1 plus F bar to the power n. The example we did, we follow that. Or we could also calculate the general inflation rate F bar as CPI consumer price index n at year n, which could be 3 years later, 2 years later, 5 years later, 10 years later. At year n, and we divide that, we take that ratio by the consumer price index at year 0, or the base that I just discussed. We take that ratio to the power of 1 over n, and we subtract 1 from that. That would give us the general inflation rate. So F bar is the general inflation rate, CPI sub n. I just mentioned that at the end of the period. So if we know the consumer price index values for 2 consecutive years, we can calculate the annual general inflation rate as F sub n bar, or F bar sub n. I like F sub n bar. CPI sub n minus CPI sub n minus 1. That's the year before that. This is the year prior to year end. Okay, that shows as n minus 1. Divided by consumer price index of the previous year, which is CPI sub n minus 1. So in this case, the general inflation rate for period n is shown as F bar sub n, or F sub n bar. So as an example, let's calculate the general inflation rate for the year 2006 based on the knowing that CPI of 2005 is 194.60 and CPI of 2006 was 200.43, meaning that the same purchasing power that we had back in 2005 by $194.6, same purchasing power is now, we can have that by spending $200.43 on an average. We do the calculation as such using this formula that I just mentioned. The CPI of n minus 1 is the year prior to the CPI sub n, which is in 2006. Remember, we're looking for a positive number here. So in this case, I mean, this number could be negative, but since 2006 was higher than 2005, and we need to arrive at a positive answer. In this case, which is, in this case, it's 3%. Okay, so we have 3 years now here in this particular problem. Yearly and average inflation rates for year 1, 2, 3, and year 0, which we use as basis given. We would like to calculate the annual inflation rates and the average inflation rate over 3 years. Obviously, in order for us to calculate it year by year, we would use the, for the first one, we subtract $538,000 from the 504. I'm having a problem with this. Okay, I got it. All right, so in this case, we are subtracting that. There's a 400 missing here. This should be a 400 right here. There's a typo. This should be really at 400. It doesn't matter much because it's not much, but $400. It's not a lot in this type of calculus. So for the first year, 6.38. The second year, 7.17%. Third year, 9.1%. Note that in order to take the average inflation rate over 3 years, we didn't just add these numbers and divide it by 3. In fact, let me do a calculation for you here. Wasn't ready to do this calculation, but it's a simple calculation. We can do it here. Let's add those 3 numbers, 6.83, okay, plus 7.17 plus 9.1, that is 23.1. Divide that simply by 3. It's going to be 7.7. Whereas the method that we use using the formula, the average inflation rate over 3 years, in this case, turned out to be 7.69%. And there is not much huge, there's not a huge difference here between just adding these 3 numbers and divided by 3. But trust me, in some situations that could be pretty large. So make sure you got, instead of just, taking the average of these 3 numbers by simply adding them up and divide them by 3 in this case, make sure you use the formula to calculate the inflation, as I just did here. Okay. That brings me to the topic of measure of inflation. Let learning continue. Thank you.